Hey guys, Mr. McKinney here, just doing our third video in the PVA series. Just got a couple of specific examples related to position, velocity, and acceleration. So this first one is if you have a table of values giving you times and distances, and you're asked to find a speed or a velocity. And I'm going to go ahead and switch to the yellow color. I think that shows up a little better. So we've recorded our distances at specific times. And the question is, how fast in miles per hour was Vader driving at 22 minutes? Whenever you see a problem like this, whatever time it gives you, you want to pick the closest 2 points on either side and just find the average velocity. Now this doesn't say average velocity, but since it doesn't give us an equation, we can't find the instantaneous velocity. The best we can do is find the average velocity going through these 2 points. So you always pick the closest point on each side and then find the average velocity going through them. So in this particular equation, we're going to do a slope calculation. So I want to do my y values, 19.7 minus 15.5 over 25 minus 20. 19.7 minus 15.5 would be 4.2 over 5, which we can simplify down. We can either use a calculator or we can just practice our mental math skills. So we can make this the same as 42 over 50, which would be the same as 84 out of 100, or 0.84. This would be miles per minute. It didn't want miles per minute, it wanted miles per hour. So if I have 0.84 miles per minute and I want to convert it to hours, I can just do 60 minutes 60 minutes is 1 hour, and this will give me a miles per hour. So if I do 0.84 times 60, I'm going to go ahead and just cheat and use my calculator, and that would give me 50.4 miles per hour. So if it asks for an instantaneous velocity, because it wanted to know at 22 minutes, but you don't have an equation, if it gives you a table of values, just pick the closest point on each side. Notice that 22 is not halfway in between. That doesn't matter. Just pick the closest point on each side. So put that in your notes. You want the closest point on each side. That's the best you're going to be able to do on this type of problem. All right, the other thing I want to cover in this video is looking at a velocity graph and thinking about the motion. What does that mean for a student? So a student recorded her motion. It tracks her velocity as she walked around for a total of 36 seconds. A graph is provided below. So this tells me the velocity of the student. Positive velocity means we're moving forward. Negative velocity means we're moving backwards. So what I want you guys to do is hit pause and describe her motion with respect to time. When is she moving forward? When is she moving backwards? And think about when she's speeding up and slowing down. So go ahead and hit pause. All right, so let's think about when she's moving forward or backwards first of all. So moving forward would mean that the velocity is positive. So we're moving forward in between 0 and let's call this, I don't know, let's call that 14 seconds. So we're moving forward from 0 to 14, and then we start moving forward again out here from 32 to 36. We're moving backwards. The velocity would be less than 0, in between 14 and 32. Now, the acceleration is the derivative of velocity. So the derivative of velocity. Now, since we don't have an equation, the way we'd find the derivative by looking at a graph would mean that it's the slope of the velocity. So if I look here, the slope is positive, which means my acceleration is positive. If I look here, the slope is negative, which means my acceleration is negative. Slope here is negative, which means my acceleration is negative. Slope here is positive, which means my acceleration is positive. And then slope here means my acceleration is positive. Now, the most common mistake is that kids say, okay, positive acceleration means those 3 times are when it's speeding up. That is incorrect. Speeding up happens when velocity and acceleration have the same sign. Slowing down happens when velocity and acceleration have different signs. So in this particular example, let's figure out when it's speeding up. So speeding up, I would need a positive velocity and a positive acceleration. So I'm going to circle those in red. So we have positive velocity and positive acceleration here. I have positive velocity and positive acceleration here. And then I have negative acceleration with positive velocity, so that'd be slowing down. Here I have negative acceleration and negative velocity. So these 3 areas in red are where I am speeding up. And then let's look in this green color where my acceleration is negative but velocity is positive, or where my acceleration is positive but my velocity is negative. These green areas are where I am slowing down. And I apologize in advance for any of you guys that are red-green colorblind. Hope this one helped. Oh, put this into your notes with a bunch of stars around it. If velocity and acceleration have the same sign, that's when we're speeding up. If velocity and acceleration have different signs, that's when we're slowing down. That's a very important thing that the AP exam likes to test. Kids assume that positive acceleration means speeding up, but that's wrong. Acceleration and velocity have to have the same sign to be speeding up. Acceleration and velocity have to have different or opposite signs when it's slowing down. All right, now that's the end of the video. Thanks.